Hello students, if you recall, we had studied how to represent a pair of linear equations in two variables graphically. We had also found the solution for the linear equations in two variables in graphical method. Further, we had discussed the questions. Then we had algebraic method for finding solution for linear equations in two variables. We had seen the method of substitution. We had solved a question based on substitution method. Before continuing the further part of linear equation in two variables, I would like to clarify some of your doubts. Cadet Rudraya Swami Hiramat had a doubt. His doubt was, if the graph of the polynomial intersects the x-axis exactly at 2 points, it cannot be a quadratic polynomial. And the answer given was true. The statement is a true statement. To understand this, we shall go back to all the types of polynomial. Let me consider a linear polynomial. The graph of a linear polynomial is a straight line. That straight line may not cut x-axis. Sometimes we get a graph such a way that the line runs parallel to x-axis. So in this case, the number of zeros is 0. In few cases, like a line cuts the x-axis at a particular point, and this point, suppose if it is x1, y1, x1 will be 0 of linear polynomial. Same way, applying the same logic, if I have a quadratic polynomial, we have these type of cases. Depending on the coefficient of x square, either we'll have an upward parabola or a downward parabola. In this particular graph, you observe it doesn't touch x-axis. Here the number of zeros is 0. Sometimes you may have the graph touching the x-axis at only one point. Here the number of zeros you may consider as 1 or 2. The reason why we have to consider either 1 or 2 is we will have the repeated roots. The zeros will be x1 and x2. Say for example, if you have x square minus 4 equal to 0, the value of x is plus or minus 4. There are clearly two roots. Suppose if the polynomial is there in this format, say x minus 4 whole square equal to 0, we will be having x minus 4 multiplied to x minus 4 equal to 0. In that case, the zeros will have a repetition. So two zeros are there for a cubic polynomial. The graph can be this. It cuts the x-axis at 3 points, or it can be in this way, where it cuts at 2 points, or it can be this way. Three distinct points. Here, exactly at 2 points need not be a quadratic polynomial. I mean, you can have zero number of zeros, one number of zeros, or two number of zeros. There are three possibilities for quadratic polynomial. For a cubic polynomial, the number of zeros can be 0, can be 1, can be 2, can be 3. Now you look at this, exactly 2 points can also be a cubic polynomial. If I generalize it, it can be a polynomial of any degree, more than 2. Let's see the next doubt. That Amreshwar was having a doubt related to zeros of cubic polynomial. If all the three zeros of cubic polynomial are positive, then at least one of A, B and C is non-negative. This statement we had discussed as false. Since it is a cubic polynomial, let me consider alpha, beta and gamma as zeros. They have given that the zeros are positive. It means alpha, beta values, alpha, beta, gamma values are greater than 0. For the given polynomial, x cube plus ax square minus bx plus c, if I consider the sum alpha plus beta plus gamma, it is minus a coefficient of x square upon coefficient of x cube is minus a. Look at the left hand side. The left hand side is positive because alpha, beta, gamma values are greater than 0. Right hand side is negative. Let me consider sum of product of two zeros at a time. That is alpha beta plus beta gamma plus alpha gamma, which is equal to minus b, the coefficient of x upon coefficient of x cube. Since alpha, beta and gamma all are greater than 0, our left hand side will be positive, whereas right hand side is negative. If I consider the product of zeros, alpha into beta into gamma, this is negative constant upon coefficient of x cube. Once again look at the left hand side, we have the positive value and the right hand side is negative. When this left hand side and right hand side will become positive, that you have to think. This right hand side will become positive only when the value of A is considered less than 0. If A value is negative, then only you will get left hand side equal to right hand side. In this case, sum of the product of two zeros at a time, we have got right hand side as minus b. It becomes positive when the value of b is less than 0. Same way, the product of zeros, the right hand side is minus b. It becomes positive only when the value of c is less than 0. Which is not possible according to this statement. They are given that at least one of A, B and C is non-negative. It has to be negative, that is why the answer mentioned was false. Cadet Shivkumar was having a doubt related to this question. Find one example each of binomial of degree 35. Binomial means two terms has to be there. So if I consider x plus 2, it's a binomial. They are given degree 35. I can consider x raised to the power 35 plus 2. This is an example. You may consider any variable raised to the power 35 plus or minus some number or plus or minus some other variable having lesser degree than 35. This is one example for binomial of degree 35. There is a sub-question and also a monomial of degree 100. You may consider some variable raised to the 400. A monomial because it is having one term and the degree is 100. This is an example, simple example. Cadet Abhishek Deshmukh was having a doubt on this question. If alpha and beta are zeros of quadratic polynomial of x square plus x minus 2, find the value of 1 by alpha minus 2 by beta. Let me rewrite the given polynomial. F of x is equal to x square plus x minus 2. Compare this with the standard form of a quadratic polynomial, x square minus alpha plus beta times x plus alpha beta. Compare this, we will get alpha plus beta as negative 1 and alpha beta will be negative 2. Now we have to make use of these two values, alpha plus beta and alpha beta, and find the value of 1 by alpha minus 1 by beta. Suppose if I consider 1 by alpha minus 1 by beta, if I take the LCM will be alpha beta and the numerator will be beta minus alpha. Now how do I find this beta minus alpha? We have already found alpha beta value. If you find beta minus alpha value, then you can directly substitute and you get the value of 1 by alpha minus 1 by beta. For finding the value of this beta minus alpha, I'll take this identity beta minus alpha whole square. I'll write it as beta plus alpha whole square minus 4 times alpha beta. You can simplify the left hand side and the right hand side. They become equal. So I have considered this identity so that I get beta minus alpha whole square as minus 1 whole square minus 4 times of minus 2. So beta minus alpha whole square is this minus 1 whole square becomes positive 1. Minus 4 times of minus 2 is a positive 8. Upon adding them, we get it as 9. So beta minus alpha will be plus or minus root 9, which is equal to plus or minus 3. So there are two different values. Suppose if beta minus alpha is taken as positive 3, what will be 1 by alpha minus 1 by beta? This will be positive 3 upon negative 2. So minus 3 by 2 is the value. And if beta minus alpha is taken as negative 3, then 1 by alpha minus 1 by beta is negative 3 upon negative 2, which is equal to positive 3 by 2. These were few doubts. Now let us continue the substitution method. I will rewrite the given equation with 2x minus 3y plus 4 equal to 0 as equation number 1 and 4x minus 6 plus 9 equal to 0 as equation number 2. We have learned in method of substitution we need to express one variable in terms of the other, and that value we are going to substitute in the other equation. Let me consider equation 1. From equation 1 we have negative 3y equal to negative 4 negative 2x. So the value of y will be negative 4 minus negative 2x upon negative 3. We can take minus as common and we get the value of y as 4 plus 2x upon 3. Now this value of y we are going to substitute in equation 2. Substituting y is equal to 4 plus 2x upon 3 in equation 2, we get 4x minus 6 times of 4 plus 2x upon 3 plus 9 into 0. Now we need to simplify this equation. 4x minus this 3 times 2 will be 6. So we can simplify and write this as minus 8 minus 4x plus 9 equal to 0. We get it as 0 times of x plus 1 equal to 0. So 1 equal to 0. So its false statement is false statement. So we can conclude hence the given system has no solution. Whenever there is no solution, we have called such type of system as an inconsistent system. If you take the ratio of the coefficients and the constant, you can see a1 by a2 will be equal to c1 by b2 and it is not equal to c1 by c2. In such type of system, we will not be having solution. Since there is no solution, it is considered as an inconsistent system or inconsistent pair of equations. We should solve another question. Solve the following pair of linear equations by substitution method. I have brought 3 varieties of questions. We shall see how to solve and we will try to understand whether we get any solution or no solution or an infinite number of solutions. Let's find it out. I'll solve these 3 different questions one by one. The first question is having equations as 2x plus 3 equal to 0, 3x minus 4y plus 5 equal to 0. Let me consider first one as equation 1 and second as equation 2. From equation 1, we can write x as negative 3 upon 2. Let us substitute x is equal to negative 3 upon 2 in equation 2. We get 3 times of negative 3 upon 2 minus 4y is 5. So we get it as minus 9 by 2 minus 4y is 5 equal to 0. So minus 4y will be equal to 9 by 2 minus 5. So if we take the LCM, it becomes 9 minus 10 upon 2. So 4y will be 1 by 2. I have answered this negative. The value of y is 1 upon 8. Therefore, x is equal to minus 3 by 2 and y is equal to 1 by 8 is the unique solution of given equations. So in this first question we have unique solution. Let us solve the second set of unique equations. Look at the equations. 3x minus 6 is equal to 0. 6x minus 12 is equal to 0. Let me write first one as equation 1 and second as equation 2. From equation 1, we have 3x equal to 6. This implies x is equal to 6 upon 3 is equal to 2. Here, in equation 2, coefficient of y is 0. So if we simplify equation 2, we get 6x as 12, simply x value is 12 upon 6 is equal to 2. Whenever there is no coefficient of y, we can consider the coefficient of y as 0. So, same equation 3x minus 6 equal to 0, same as 3x plus 0 times y minus 6 is 0, and 6x minus 12 is equal to 0 implies 6x plus 0 times y minus 12 is equal to 0. For both these equations, the value of x remains same. Value of x is 2 and value of y can be any number. It can be any real number. Hence, system has infinite number of solutions. Understood? Let us take up the next question. In the next question, we have x plus 3 equal to 0 and 2x plus 5 equal to 0. As we have learnt in the previous question, that when y coefficient is 0, we can write the equation as x plus 0 y plus 3 is 0, and second equation can be written as 2x plus 0y plus 5 equal to 0. Let me name this as equation 1 and this as equation 2. From equation 1, we have x value as 3. From equation 2, we have 2x equal to negative 5, and it is negative 5 upon 2. We can compare these two. The value of x are different. Since x value obtained is not the same, the given equations are inconsistent. Since x values in both the equations are not same, the system is inconsistent. So when inconsistent system is there, we conclude that there won't be any solution. Let us solve another little difficult question. The equations given are in terms of variables and a and b. In such type of question, how we can use the method of substitution. We name this equation as equation 1 and this one as equation 2. From equation 1, we have a by x equal to b by y. So if you cross multiply, we get a is equal to bx. So y value is bx upon a. Let me now substitute y is equal to bx by a in equation 2. So if we substitute, we will be getting a b square upon x plus a square b upon, in the place of y we have to replace bx upon a. So bx, it becomes into a, which is equal to a square plus b square. Let us further simplify. This b get cancelled and our equation becomes a b square upon x plus a cube upon x equal to a square plus b square. Take LCM. LCM will be x. We get ab square plus a cube equal to a square plus b square. We need to find the value of it. So I will cross multiply and equate it, and it becomes x is equal to, if a is taken common, we will be getting b square plus a square upon a square plus b square. These two are one and the same, so we can cancel it out. The value of x becomes 2. Since we got the value of x as a, then y will be equal to b times of a upon a. A will get cancelled. The value of y will be, therefore unique solution is a comma b. X value is a and y value is b. Let us now take up a question and let us solve that particular question by another method, the second method, the method of elimination. The word eliminate means you have to remove that particular term. Here we have got equation as 78x plus 91y equals and 65x plus 117y equals. To solve In elimination method, let me write these equations and name them as equation 1 and equation 2. To eliminate, I'll follow either addition or subtraction. But then, to cancel this x term or the y term, I have to make their coefficients same. To make their coefficients same, let me multiply equation 1 by 5 and equation 2 by 6. If I do that, I'll be getting x coefficient as the same. If I is multiplied to 78, we will be getting 390. 390x plus 91 5 times is 55. 5 equal to 53 5 times is 265. Now if the second equation is multiplied by 6, the x coefficient is 390, the y coefficient becomes 702, and if 6 is multiplied to 60, we get 360. Now to eliminate, I would like to subtract. Now if you subtract, this 390 will get cancelled, 390x will get cancelled. If 455 is added to negative 702, we will be getting 247 minus 245 equal to, if minus 360 is added to 265, we will be getting it as negative 95. So the value of y is negative 95 upon negative 257. We can simplify this further. It becomes 5 upon 13. So the value of y is obtained. Now to get the value of x, I have to consider any one of the equation and substitute the value of y. So let me take substitute y is equal to 5 by 13 in equation 1. We will be getting 78x plus 91 multiplied. In the place of y, I have to take 5 upon 13 into 53. Now you need to simplify. 13 7 times is 91. So 78x plus 7 multiplied to 5 will be 35 equal to 53. To transpose 35 to the right hand side, we get 78x equal to, what is 53 minus 35? 18. So x value is 18 upon 78. 18 and 78 are divisible by 6, so it becomes 3 upon 13. So we got the value of x and y. Therefore, solution is x comma y equal to 3 upon 15 comma 5 upon 13, which is an unique solution. This is how we have to use method of elimination. Eliminate either x term or y term, then substitute the value obtained in the one of the equation to get the value of the variable. If you have understood this elimination method, you will be able to try this question. I'll be giving you 4 questions. You have to solve these 4 pairs of linear equations by elimination method. You can eliminate either x term or y term in the equation. Try these questions. We'll continue some more questions in our next session, and also we will learn a new method, the method of batch multiplication.